So this is our Shiva sir. Today we are going to discuss about magnetic effects of electric current. In the previous class, we discussed same topic until magnetic effects of electric current I discussed. So today also we will go with the few topics, same thing, magnetic effects of electric current. So once again we will recall the topic. So magnet is a substance which attract the magnetic materials. Magnet is a substance which attract the magnetic materials. The substance which attract the magnetic materials is called magnet. And here the natural magnet is magnetite. Magnetite is the natural magnet. Hi, it's Saturday. Please, sir, I want light chapter full. Okay, Anhad. So we'll see. Definitely. So today we are going to discuss about magnetic effects of electric current. A light chapter I will explain. I will plan. Okay, I will let you know. So if it is completed today, I have exam on Monday. Okay, fine, no problem. So tomorrow, Sunday is there, right? Tomorrow also I will take the class. Tomorrow also I will take the class. Then I will explain. Now if it is completed today, magnetic effects electric current is not coming to my exam. Okay, very nice. So, but still, it is there in syllabus, right, for board exam. So you can listen. So anyway, I'll explain. So my light chapter, I'll explain. So definitely, I'll explain. Not now because already scheduled magnetic effects of electric current, right? So I'll explain. So tomorrow I'll plan. Okay. So tomorrow I'll plan. I'll inform by end of the class. Either a morning or evening. Evening 6 o'clock also I'm taking class. Anhad, 6 o'clock also I'm taking the class. That time if it is possible I will take okay. So magnet light chapter. Actually every day I'm taking about light chapter also. Light chapter only. Light chemical reactions and equations. Light process is coming and I don't study light. Uh, I don't study light a little bit. Okay, okay. So definitely. So I'll explain. You'll get it. Definitely you'll get it. Okay. So light chapter I'll explain. So I scheduled today magnetic effects of electric current. If you could inform before, may start. So light chapter it will take nearly around 1.5 hour, 2 hours. That is a big chapter. Big chapter because topics are lengthy. So lengthy topics are there. Even including problems if you are one, so it will take time minimum 1.5 hour to 2 hours if you have clear explanation. So normally if concepts are enough, so important topics are okay means maximum 45 to 40 minutes to 1 hour it will complete light chapter. So only concepts, only concepts. So if clear okay in detailed topics 6 a.m. or 6 p.m. 6 p.m. evening time. Evening time I will take class. Evening time. Okay. So evening time if I take, then it will be better. No. So remaining students also can join along with you. So I'll explain. So tomorrow, 6 p.m. you can join. I'll plan a light chapter. So remaining students, those who want this light reflection diffraction, you can let me know. I'll start tomorrow evening. Magnetic effects of magnetic effects of electric current. So chapter is very very important chapter. Here expected question, 5 marks question expected. 5 marks question is expected from the chapter. 5 marks question. Okay. 5 marks question is expected, like a current carrying conductor placed in the magnetic field. And a 3 marks question also expected. So from the chapter, 3 marks question. The there is a difference between magnetic field and bar magnetic field. A magnetic field of solenoid and a magnetic field of bar magnet. Differences they will ask. And 2 marks expected. So magnetic field properties of magnetic field lines. And 5 marks question can be expected. 5 marks question is current carrying conductor placed in the magnetic field. And one more question also. So 2 marks question is we can go for a Fleming left hand rule and a right hand thumb rule. So rules are very, very important. In the chapter, rules also very, very important. I will explain in detail this chapter. I hope in the yesterday class I explained. Yesterday class I explained few same topic only, like magnetic properties, artificial magnet, natural magnets. Natural magnets example, natural magnet is magnetite is a natural magnet, magnetite is a natural magnet, so that is also called lodestone. Natural magnet is called lodestone. Lodestone is a natural magnet. Artificial magnets, man-made magnets, so those are called artificial magnet. Artificial magnets we can see bar magnet, U-shaped magnet, like a horseshoe magnet or U-shaped magnet, dumbbell-shaped magnet, cylindrical magnet, spherical magnet. There are number of magnets are there. So in the chapter particularly we will discuss about bar magnet, magnetic field and everything. So here the magnetic field we will discuss. So magnetic field. So magnetic field, if you are considering the magnetic field, so I am taking here, this is a bar magnet, this is a bar magnet I am considering here. Okay, so this artificial magnet, bar magnet, I am considering. See, magnet has 2 poles. Bar magnet has 2 poles. So these 2 poles have equal strength. These 2 poles have equal strength. Equal strength. When you drop this magnet, if you drop the magnet into the sand, what happens? If you drop the magnet into the sand, what happens? Automatically it will attract the magnetic materials. So magnetic strength will be equal for the poles, north pole and south pole. Magnetic strength will be equal for these poles. So here magnetic strength. So magnetic strength of north pole and south pole will be equal. So equal amount of attraction will be there when you drop this magnet into the sand. So at these poles more attraction will be there than in the middle. You can observe, if you drop the magnet, so more iron fillings, more magnetic materials will attract at this end, at this ends. So it is not completely at the little inside it will be there. So there poles will be there. So the poles will be there. So pole strength will be more. So if you break, so I am taking this magnet. So if you break one more piece, so if you are breaking into 2 pieces, again this magnetic piece have again 2 poles. Again this magnet has 2 poles like that. So again if you are taking like this, again it has 2 poles. Again it has 2 poles like this. So if you break each and every time again, so the magnet will be having 2 poles. Okay, so that is about magnet. Okay, so magnet and magnetic poles. Next one, and strength of the magnetic field also. The field will be more, as I said, the field, the region around the magnet in which magnetic force exert. The field, the region around the magnet, around this magnet, the field will be there. So until certain range only it will attract the magnetic materials. So beyond, so if I place the any magnetic material like iron if you place, so it will attract until this point only. If you place beyond this point, it won't attract. So at certain region only it will attract. The region around the magnet in which magnetic force exert, that is called magnetic field. That is called magnetic field. Okay, so that is about magnetic field. The magnetic field will be in the form of field lines. How the field lines will be from north to south. So if you are taking like this, so the magnetic field lines will be north to south, like this it will be there. So north to south around the outside of the bar magnet, the magnetic field will be north to south. Inside of the bar magnet, the magnetic field will be south to north. Outside of the bar magnet is magnetic field will be north to south. Inside of bar magnet is south to north. So this is about magnetic field and field lines. So field lines, you can see there is a 3 marks question about field lines, magnetic field lines, about a magnetic field lines. So here, if I want to find the magnetic field at this point, I want to know the direction of the magnetic field at this point. How can I identify? Anyone can tell? How can I identify? Hi. Hi, Daniel. How are you? I'm fine. Yeah, yesterday some technical issue. That is the reason I couldn't able to read the messages. At end of the class, I saw that messages. At end of the class, I saw that messages. So that is the reason I couldn't able to respond yesterday. Sorry for that. Okay, so I'll make sure that the technical issue will not repeat once again. Okay. So now I'm considering here at this point, what is the magnetic field direction? If I want, so please teach singing way like that. Okay, so definitely I'll try. Okay, Daniel. So if I'm taking here at this point, I'm considering at this point here at this point. So I want to find the direction of the magnetic field. How can I find the direction of the magnetic field at this point? So anyone can tell? So actually, if you draw actually we know the magnetic field will be in the form of field lines. I already said magnetic field lines will be in the form of field lines. Magnetic field will be in the form of field lines. So at this point, so if you draw the tangent to the curve, along the direction, the magnetic field will be there. Along the direction, the magnetic field will be there. Tangent means the line touches the curve. The line touches the curve at one point. That is called tangent. If you draw the tangent to the curve, so along the direction, the magnetic field will be there. Okay, so this is about the magnetic field and the magnetic field direction. Now, properties of the magnetic field very important. Properties of magnetic field. So I'll explain properties of the magnetic field. So what are the properties that exhibit? So what are the properties? So I'm considering here. I'm taking this magnet. I'm considering this a magnet. This is the north pole and this is south pole. The magnetic field will be there. Okay, so around like this, I'm considering here the magnetic field. So first point is, so the magnetic field lines are closed loops. As a magnetic field lines are closed loop. These magnetic field lines are closed loops. Okay, so these magnetic field lines, if you see, these are closed loops. Okay, these magnetic field lines are closed loops. First point is closed loops. Second point, coming to the second point. So I'm recalling the topic. Once again because very important. 3 marks question will come from this chapter. So this especially this magnetic properties of magnetic field lines. These are the properties of magnetic field lines. Properties of magnetic field lines. Magnetic field lines. So properties of magnetic field lines. What are those? So first point, these are closed loops. Second one, it starts from north and reaches to south. So start from north, reaches to south. And third point is, so these magnetic field lines never intersect. Okay. So never intersect. Magnetic field lines never intersect. So if it is intersect, so at the point of intersection, if you are taking like this, okay, so at this point, if these two lines intersect, compass. So what is compass? Inside of compass is nothing but a small magnetic needle is present inside of it. So compass is nothing but a small magnetic needle is present inside of it. So it shows always north and south direction. If you are considering north and south direction, this is north, this is south, and this one is east. and west. North, south, east, west. North, south, east, west. North, south, east, west. So you can see, if you place the compass, always it shows north and south direction. Always it shows north and south direction. So if the two lines intersect, so if the two lines intersect, so what happens? So compass should show at that point of intersection two directions, where it is not possible, right? So we cannot show, compass cannot show at a time two direction. At a time two direction, it won't show. So that's why those field lines never intersect. So never intersect. These are the 3 points, very very important. 3 points, very very important. Closed loops, it reaches to north to south outside. This is the outside of the bar magnet. Outside, we can say outside. Inside of the bar magnet is south to north. The direction of the magnetic field inside of the bar magnet is south to north. There is a question will be there on this point. So magnetic field will be outside of the bar magnet is north to south. Inside of the bar magnet is south to north. Okay. So closed loops and north to south, and this field lines never intersect. These field lines never intersect. Okay, these field lines never intersect. Very very important point. So make sure that you are learning these points. So very very important. 3 marks question, even 1 mark question also, even MCQs also will get these questions. Even for 1 mark also these questions will come. 3 marks question, 1 mark question, even 2 marks question also they may give. So diagram definitely 3 marks question. Bar magnet and solenoid. So I'll explain the solenoid. That is also very very important. This is about magnetic field of bar magnet. So I'll draw how to draw the diagram. Okay, so how to draw the diagram, I'll show you how to draw the diagram. Okay, so for a neat and clear proper diagram, how to draw. In exam, if you draw like this, you will get maximum marks. Means if it is for 3 marks, maximum according to your presentation, you will get 3 marks. And if they ask any question related to properties, related to explain the magnetic field of bar magnet, like that. So I'm considering here. So exactly take sufficient place. So select a sufficient place and mention north pole and south pole. Don't mention at the ends. So little inside you have to mention. And you can take the lines, either 7 lines or 9 lines. So these two numbers are preferable. So sir, why we have to take only 7 and 9? Why can't I take either 5 or 11 or like that we can? So why can't we take? You can take. See, if you take 7 and 9, I will show you how it will be. So I'm taking 7 lines. 1, 2, 3, 4, 5, 6, 7. Okay. So 1, 2, 3, 4, 5, 6, 7. So if you draw like this, point number 1, you take 2 lines at the top. So like this, you can take like here. Okay, so you can take here. And one more, you can take bottom like this. And second, you can take one more line. Okay, so and one more line you can take here. Okay, 2 lines at the top, 2 lines at the bottom. Then you can draw 3 lines in the middle. 3 lines in the middle. Now you see how it is, the diagram. We can take 9 lines also. 9 lines if you take. So here I'm taking 9 lines. So one here, and one more I'm considering here, and one more I'm considering. So like this, 3 lines, and here one more line. That's enough. So top, you can take 3 lines. So 3 lines at the top, 3 lines at the bottom, 3 lines in the middle. Then it looks clear. It looks good. It looks great. Okay. So however you draw the diagram, and so the directions also you have to place like this while you are placing the directions. So place like this. So all the lines must be in single line. If you draw the straight line, it looks like. If you are not getting how to draw, you can use scale. So you can place the scale like this. So I'll show you how it is. So just for You can place scale like this. If you want, you can place scale like this. Okay, and you can draw. Okay, no need to draw the line. No need to draw the line. Just you can place and mention the directions, arrow marks. Okay, next one here. At this point also you have to mention the directions. At this point, and here also you have to mention the directions. So here inside, so magnetic field should reach towards north. Here magnetic field reach to so it should move away from it. It should move away from it. Here magnetic field should reach to this point. Magnetic field should reach to the point. Clear? So this about magnetic field, bar magnetic field, and so place. So put the box like this, and okay, mention magnetic field, bar magnetic field, bar magnet magnetic field. Clear? Or magnetic field of bar magnetic field, or magnetic field of bar magnet. Anything is okay. Clear? So like that you have to draw. Like that. If you draw like this, so it is very easy. You can get good marks. Maximum marks you'll get 3 marks. And you can explain also diagram. Okay, magnetic field around the magnet will be there. So magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. Okay, so the magnetic field starts from north. Start from north and reaches to south. Start from north and reaches to south. Our magnetic field leaves the north pole and reaches to the south pole. Okay, and here the field will be in the form of field lines, and the properties also you have to learn. So properties, the definitely 3 marks question. 3 marks question, properties, magnetic field lines properties, 3 marks question. Make sure that you are learning properties of magnetic field lines, properties of magnetic field lines, magnetic field lines, magnetic field lines. So 3 marks question, very important question. So expected question for board exam. So properties of magnetic field lines. Okay, 3 points I'm saying. One is, so magnetic field. So these field lines are closed loops. Closed loops. Start from north, reaches to south. Second one, closed loops start from north and reaches to south pole, and these field lines never intersect. These field lines are never intersect. If it is intersect, so at the point of intersection, the compass should show 2 directions where it is not possible. Compass should show 2 directions where it is not possible. Clear? So I hope it is clear, the concept. I'm going to the next concept. So I'm considering here. So right hand thumb rule, if the current is passing through the magnetic side conductor, if the current is passing, if you have any doubts, you can ask. So you can comment. Okay. So I'm taking here. I'm considering here. So if you are taking the straight conductor, so if I'm taking the conductor, current is passing, current is passing. Okay, current is passing, current direction. So how can we identify the magnetic field? So how can we identify the magnetic field? By using magnetic field. Anyone knows? So how can we identify the magnetic field direction? Magnetic field direction. So when the current is passing through the conductor, it acts as a magnet. It produces magnetic field. It behaves as a magnet. It produces magnetic field. It behaves as a magnet. So it magnetic field will be formed around the conductor. How can you identify the magnetic field direction? So which rule we will use to identify the magnetic field direction? So by using right hand thumb rule. So you can see my hand. So this is my hand. So no magic. So all only rules. Okay. So only rules are there. So if you take the conductor, I'm taking the thumb. along this direction, along this direction. So thumb shows along the current direction. Curly fingers, folding fingers, curly fingers, folding fingers, curly fingers, folding finger, curly fingers, folding finger shows magnetic field direction. Okay, so if the current is passing in the conductor, if the current is passing in the conductor, understood. Very good, very nice, excellent, marvelous, mind blowing. Then, how can we identify the magnetic field direction? Which rule we will use? We will use right hand thumb rule. We will use right hand thumb rule, 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 current direction. Take the thumb finger along the current direction. Curly finger shows magnetic field direction. Folding fingers, curly finger shows magnetic field direction, shows magnetic field direction, magnetic field direction, magnetic field direction, magnetic field direction, magnetic field direction. So I hope it is clear to you all. Next, so now I am considering here. So here around this one, magnetic field will be created, magnetic field will be produced around the conductor by using right hand thumb rule, by using right hand thumb rule, by using right hand thumb rule, right hand thumb rule, right hand thumb rule, use it to find the magnetic field around the conductor, around the conductor. So I hope it is clear to you all. So to find the magnetic field direction around the conductor, we will use right hand thumb rule. Okay, so how we have to use? So if you take the thumb along the conductor direction, current direction, curly fingers, folding fingers shows the magnetic field direction. Clear? So next one, I am going to the next one, next one, next one, next one, next. Next one, next one, next one. So till now we discussed about straight conductor. Now I am going to the loop. So I'm going to the loop question. So if you see, a loop I am taking. So this is a loop. Like this, positive, negative, positive, negative. Saru, I have question. Here you are taking the loop. Very good. I am very happy. Sir, the magnetic field will be more at the circumstance or at the center, sir? Magnetic field will be more at the circumstance or center, sir. Please clarify that doubt, sir. Please clarify that doubt, sir. Okay, so I'll clarify the doubt, that is. So here, if you're taking the current like this, current is passing here. Yes or no? Yes. So magnetic field will be there. Yes, magnetic field is there. Yes, sir. Magnetic field is there here. Yes or no? Magnetic field is there. Yes, sir. Magnetic field is there. So when you keep on going, the field lines become parallel lines. Field lines become parallel lines. So here north pole. So here south pole. How? So if you are taking the current direction like this, so the magnetic field will be reaching and leaving here. Leaving this side, reaching to this side. So reaching, leaving, so leaving, reaching. So like that we can identify the magnetic field, right? So magnetic field we can see. So now this is a north pole, this is a south pole. Sir, I have one question. So here current is passing. Current is passing here, right? Yes or no? So here in the wire itself, current is passing in the wire. How the field will be here at the center? How the field lines will be more at the center? How the field will be more at the center? Actually, when the lines are keep on moving, So when the current is passing through the conductor, it acts as a magnetic field. The magnetic field will be there. So at near the conductor, the magnetic field will be more. So when you are moving away from it, the magnetic field lines become parallel. So here, if the lines are parallel like this, if the lines are parallel, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the field lines are like this, 1, 2, 3, 4, 5. So the field lines like this. So this magnetic field will add up to this magnetic field. So next magnetic field will add up to another magnetic field. This magnetic field will be added up to another magnetic field. Then, so what happens if the magnetic field is adding up to the another line? Then what happens? The magnetic field will be uniform at the center. So at the center, the magnetic field will be uniform. More magnetic field will be here. More magnetic field will be there. At the center, more magnetic field will be there. More attraction will be there. So that's why at the same time it is uniform. It is uniform. So when it is coming at the center, the field lines become parallel lines. Field lines become parallel lines. Field lines become parallel lines. The magnetic field will be more at the center. Magnetic field will be more at the center. So this question will come for 3 marks. This question will come for 3 marks. Very important. And also it will come for 1 mark also, 1 mark also, 1 mark also, 1 mark also, 1 mark also. It will come 1, 1, 1, 1, 1, 1, 1 mark. So this question come for 1 mark also and 3 marks also. Sir, how it will come? How the question they will ask? How they will ask in the exam? So in a loop, if the current is passing in a loop, so where the magnetic field will be more? At the center or at the circumference? At the center. Answer is at the center. So like that MCQs also they will ask. And explain the magnetic field pass or explain magnetic field is produced around a current carrying loop. If you say it is loop, like that we are considering, right? So now, sir, until here it is clear, sir. You said straight conductor and loop. If I take 2 more, 3 more loops, what happens, sir? How we have to be, how the magnetic field will be, how the magnetic field, how can we find out North Pole, South Pole? Can you explain, sir? Yes, I can. I will explain. So if you are now, I consider. So now just now I took only single loop. Just now I took only single loop. If I take number of loops, if many loops, if I consider, if I take number of loops, how the magnetic field will be there, how the field lines will be there. So how can we identify the North Pole and South Pole? And how it will act? Is it magnetic field produced by these lines is same as a Bohr magnet? And how the magnetic field between Bohr magnet and this loop magnetic field, is it same or any difference? Is it produce same magnetic field or any changes in the magnetic field or poles or everything? So now we will discuss. So I'm considering here. So this loop, I'm considering the loop like this loop. So taking the straight wire, straight wire, you take a straight wire. So wrap in the form of cylindrical shape. Take straight wire. Wrap in the form of cylindrical shape. Connect to the battery. 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 So I am connecting to the battery. Here I am considering positive terminal, negative terminal, positive terminal, negative terminal switch. So switch is here, connecting pass. Current is passing through it. Current is passing through it. Current is passing in the loop. Yes or no? Yes. Magnetic field will be produced by the loop. Yes or no? Yes. So how the magnetic field will be there? So we will draw here. As I said before, either 7 lines or 9 lines you can take. 7 lines or 9 lines you can take. So I am taking 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, and 9 here. Okay, so I'm taking 9 lines. Sir, why we have to take 9 lines only? We can take 7 lines, we can take 5 lines, we can take 11 lines. Yes, 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 yes. According to your requirement, how you want to draw, you can draw. But my preferred number is odd number, that is 7 and 9. 7 or 9. Either 7 or 9 if you take. So the diagram looks good. Great. Okay. So and it appears, it's like a diagram like that. So you, here I'm considering here. So 3 lines you can take top at the top. So I'm taking 3 lines here at the top like this. I'm considering 3 lines. At the bottom also you can take 3 lines. At the bottom also you can take 3 lines. I'm taking 3 lines at the bottom. Like this. Okay. So 3 lines at the top and 3 lines at the bottom and 3 lines in the middle. So I'm considering current is passing here. Current is passing like this. So this I'm considering south. This I'm considering north. So current is passing, magnetic field also will move towards this point. Okay, so actually here the current is passing through it. So through loop. So it acts as a magnet. So magnetic field will be produced. So at this point current is leaving. So blind mark is current is leaving. So magnetic field also leaving from this side. And here also current is passing here. So magnetic field is moving. Sir, how can we identify these poles? And here, so actually by using compass, if you place compass, we can identify the magnetic field of this side and this side, both ends. So proper perfect method is identify by using compass. So here one logic is there. I will tell one thing. So best example. So take a thread. So if you wrap over the cylindrical shape like this, so this is one connection, and we can wrap below also, right? We can wrap below also. Then current direction changes. Right? Yes or no? So I'll show you one example. You can see. I'm taking here. So I'll show you one example. Okay. You can see here how the paper direction, the magnetic field. So suppose if you consider current direction, I'm considering. If you take the current direction, anti-clockwise or clockwise? Anti-clockwise or clockwise? Can you tell? Anti-clockwise or clockwise? Clockwise direction, correct? Huh? So like this. You can consider here. Anti-clockwise or clockwise current direction? Clockwise direction. So if you see the back side exactly, how it is? Anti-clockwise direction. Okay. So the view, if you change, automatically direction of the current also changes. That is simple. If you are taking like this, So current is clockwise direction, or current or magnetic field. Suppose you consider like that. So current direction. So if you change this, same way it will become anti-clockwise. Anti-clockwise. Yes or no? Anti-clockwise. See, same thing here also. The view we have to change. If you change the view, automatically direction also will changes. Direction also will changes. So here also I am saying, so along this direction, according to wrapping the wire, it changes. It differentiate. Clear? So that is about a magnetic field. So here the point is, I will draw one more point. I am considering bar magnet. I am drawing. So here bar magnet you can see. This is a bar magnet. Here is north. This is south. So the magnetic field is here like this. So magnetic field will be like this. So here magnetic field is moving away from the, here magnetic field is reaching. So the difference between solenoid and bar magnet is, so this is a bar magnet. The difference between solenoid and bar magnet. So first point is so here for solenoid also magnetic field will be there. For bar magnet also magnetic field will be there. And for solenoid also poles are there. For bar magnet also poles are there. Second point. Okay. So here the magnetic field lines are closed loops. Here also magnetic field lines are closed loop. Differences. Coming to differences. So here you can see this field line, this field strength is fixed. Magnetic field is fixed. Coming to the magnetic field of bar magnet and solenoid. Magnetic field is fixed. Magnetic field is fixed for bar magnet. Magnetic field for solenoid changes. How it will changes? By changing the battery. If number of cells, if you add number of cells, what happens? If you add number of cells, magnetic field also will changes, right? Because number of current is passing through the loops, strength of current. Okay, current passing through the loop also will increases, then automatically strength, magnetic field strength also increases. Second point, so coming to the second point, here, so poles are fixed. So north and south, here north and south poles are here. Bar magnet poles are fixed, but solenoid poles can be interchanged. So if the current is passing in this direction, the field will be south and north. If current is passing in a reverse order, if the current is passing in a reverse order, that time the field will be, if the current is passing in a reverse order, so the poles will be interchanged. So like that. So poles can be changed. And and third point is magnetic field depends on current. Magnetic field depends on current and number of loops. Magnetic field depends on current and number of loops. Magnetic field depends on current and number of loops. Magnetic field depends on strength of the current and number of loops and air gap, the gap between the loop to loop. So if gap is more, magnetic field is more. If gap is less, magnetic field is less. So accordingly, so we can take. So this is about magnetic field between bar magnet and solenoid. So this question will come. So either similarities, dissimilarities. So similarities and dissimilarity between these two question. Okay. So difference between solenoid and bar magnet of magnetic field. So what are the similarities and what are the dissimilarities? So this type of questions they will ask for 3 marks. So very, very important question. So practice the question. And the next one, so we are going to the next one. So that is about solenoid. So then I am going to the current carrying conductor placed in the magnetic field. 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 We'll discuss that one. So I'm considering here. So this I'm taking the stand. Sorry, the support. This is stand. So I'm considering here. So this is the supporting rod. I'm taking the magnet. This is the aluminum rod. I'm considering here. Aluminum rod. Okay, so here is aluminum rod. So I'm connecting to the battery. So I'm connecting to the rod. So like this. So here you can see. So now you can observe. So I'm considering now. So here you can consider I'm taking the magnetic field. So side conductor. This is a conductor. So current is passing like this. Switch. So current is passing like this. Okay. So positive terminal, negative terminal. So you are placing here magnet. I'm placing here. I'm placing the magnet here. So this is north and this is south. So actually if the current is passing in the conductor, so the current direction will be like this. So current is passing like this. So you can observe one thing here. If the current is passing this direction, so if the current is passing in the conductor, it acts as a magnet, right? Generally it acts as a magnet. If you take two magnets together, what happens? If you place two magnets together, what happens? Either it will attract or repel, correct? Either it will attract or repel. Okay, so if I'm taking this way, this is also magnet. So this external magnetic field. So U-shaped magnet, this external magnet. So in external magnet, so we are placing the conductor. In external magnet, so we are placing this conductor. Yes or no? We are placing this conductor. So we are placing this conductor. Correct or not? This conductor I am placing here at this point. So there repulsion or attraction will take place. Repel. Okay. So by using which rule we can identify the force on the conductor? By using Fleming's left-hand rule. By using Fleming's left-hand rule, we can identify the force on the conductor. By using Fleming's left-hand rule, we can identify the force on the conductor. So here you can see, index finger shows the magnetic field. Middle finger shows the current direction. Index finger shows the magnetic field. Middle finger shows the current direction. Thumb shows the force acting on the conductor. Once again, index finger shows the magnetic field. Middle finger shows the current direction. So if your magnetic field is like that, so current is like this. So current is downward direction. Magnetic field is upward direction. Current is downward direction. So in which direction thumb is showing? Inward, towards the board. So the conductor will move towards the board. Okay, conductor here. Which one will move? Conductor will move. Not this setup. Not this entire battery switch. It won't move. And this external magnetic field. This is the horseshoe magnet. Here is north. and here is south, here is south. Okay, and this conductor will move. This conductor will move. How? By using Fleming left hand rule. Index finger shows magnetic field. So middle finger shows the current direction. Thumb shows force acting on the conductor. Force acting on the conductor. So the conductor will move towards the board. Towards the board. So this is about current carrying conductor placed in the external magnetic field. Experience the force. Current carrying conductor placed in the magnetic external magnetic field experience the force. That is about question, and actually this question will come for 5 marks. So 5 marks I said. So this question will come for 5 marks. Okay, so which, and rule also, Fleming left hand rule also will get for 2 marks. Fleming left hand rule also will get for 2 marks. Okay, so they will ask in the exam for 2 marks. And last in previous exams they will ask about current carrying through straight wire. Current carrying through straight wire, how the magnetic field will be produced, how it will be. So like that they asked. That is about this is about current carrying conductor placed in the external magnetic field experience force. Experience the force. Now next one will go for live wire. Live wire. Live wire is positive wire. Live wire is positive wire. Live wire is positive wire. Neutral wire is negative wire. Live wire. So live wire I'm considering. Live wire is positive wire. Live wire. Neutral wire. Neutral wire. Neutral wire. Live wire and neutral wire. So earth wire, earth wire, earth wire, earth wire. So here we can consider live wire is positive terminal, red insulation, so red color. So neutral wire is negative terminal, black color, black color. Earth wire is green color. Earth wire is green color. So these were very important. So the potential of live wire is 220 volt. The potential of neutral wire is 0 volts, and the potential of earth wire is 0 volts. So if they ask the potential difference between live wire and neutral wire, the potential difference between live wire and neutral wire is 220. So very important. So this question expected to come in board exam, 220 volts. So the potential difference between live wire and neutral. See, alone they will ask for live wire is 220. Alone they will ask for potential of neutral wire is 0. Potential of earth wire is 0. Potential difference between live wire and neutral wire is 220 minus 0, 220 only, 220. And the potential difference between live wire and earth wire is also 220. Live wire and earth wire. The potential difference between live wire and earth wire is 220. But the potential difference between neutral wire and earth wire is 0. The potential difference between neutral wire and earth wire is 0. The potential difference between live wire and neutral wire is 220. Potential difference between live wire and earth wire is 220. Potential difference between neutral wire and earth wire is 0. Okay, so these are very important points. So make sure that you are okay. So learning these points, definitely one question will come for board exam, and your SLEP test, unit test, post midterm. So any so in any exam, this type of questions they may ask expected. So this question can be expected in exam because they will touch the basics. So these are very basics, fundamentals. Okay, so next one we'll go for we can take short circuit and overloading. Short circuit is nothing but the direct contact of live wire and neutral wire. So if direct contact of live wire and neutral wire takes place, then a heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. So direct contact of live wire and neutral wire, then heavy amount of current will be drawn from the main. Then it leads to short circuit. It leads to the short circuit. Okay, so fire will occur in the building. So overloading. Coming to the overloading. Overloading, if you are taking overloading is nothing but so if heavy electrical appliances, high voltage appliances like a geyser, a washing machine, grinder, AC, so like this, if you high voltage appliances on at a time, heavy amount of current will be drawn from the mains. Hi Tanishka. So almost ending your joining today, little bit late, huh? So you came at End of the class. Almost I completed the chapter. Okay, fine, no problem. So I'll explain the chapter once again. Okay, so to actually almost ending. From 9 o'clock I started. 9 o'clock I started and explained entire chapter. Magnetic effects of electric current. Okay. So coming to the overloading. Overloading is nothing but heavy high voltage appliances, AC, washing machine, geyser, so fridge. If you on all these appliances at a time, what happens? Heavy amount of current will be drawn from the mains. Then it leads to the short circuit. Then fire will occur. Fire will may occur. So that is about short circuit and overloading. So very important terms. These are short circuit, and overloading. And one more point. So based on this one question will come. One question will come. Sir, why you are saying all important? All questions are very important. So you are saying every question it's like a final destination. It's like a final, okay, final episode like that. You are saying it's like a end card like that. You are saying. So which question will come? Which question I have to practice? So you can tell. So right now I can't tell because when I'm explaining the chapter, so in I saw many papers, even board exams also over this many years I observed. So the point is in these areas they will ask the questions. So whatever I am explaining, whatever I discussed, all the points in these areas only they'll pick the questions. They will give the questions. Short circuit, overloading, and AC and DC graph they will give. So related graph if you are taking, so alternative current will be like this, and direct current if you are taking the graph like this, so direct current. Okay, direct current I'm considering. So the graph also they will give. So related to graph also they will ask, and direct current, alternative current. So like this. So that type of questions they will ask, and overloading, overloading and short circuit also they will ask. Okay, so related to this type of questions they will ask, and overall briefing of the chapters. Once again, I will explain like a briefing where exactly we need to work out. So where we have to focus. So from starting onwards, whatever I explained till now, magnetic effects of electric current. First we have to talk about magnet. So related to magnet is a substance which attract the magnetic materials. So magnetic materials. So natural magnet is magnetite, and lodestone. Natural magnet is magnetite and lodestone. So are lodestone because in olden days so this stone is leading them to move forward. That's why it is called leading stone. So my offline classes are there. Hi sir. Offline classes are there till now. Today is Saturday, right? Okay. Done, fine. So you can join. So definitely I will explain. So remaining topic, this chapter completed. Tomorrow I'm planning for a light chapter. Light chapter. Okay, so join to the class. So 9 o'clock, if it is possible, try to join at 9 o'clock. So I sharply, if any concern is there, I'll inform. If not, generally I'll start at 9 o'clock. Okay, like any technical issues, any concerns. Other than that, definitely I'll start at 9 o'clock. Sharp 9 o'clock, I'll start. And coming to the next one, natural magnet and artificial magnet. So natural magnet is magnetite, and artificial magnets are bar magnet, dumbbell shaped magnet, U shaped magnet, cylindrical magnet, spherical magnet, like that. All these type of. So we talk about bar magnet and magnetic field. So magnetic field is nothing but the region around the magnet in which magnetic field, the region around the magnet in which magnetic force exerts. That is called magnetic field. So magnetic field will be in the form of magnetic field lines. Magnetic field lines, okay, so start from north, reaches to south. At the same time, magnetic field lines are closed loops. And on one more thing, these field lines never intersect. If it is intersected at the point of intersection, so the compass should show two directions where it is not possible. That is about so properties of magnetic field lines. Very important. 3 marks question will come for the 3 marks question will come. And coming to the right hand thumb rule, by using right hand thumb rule, we can identify the magnetic field direction. So thumb shows the direction of the current. Curly finger shows the magnetic field direction. And coming to the next one, right hand thumb rule, loop is there. So at the center, magnetic field will be more, and straight conductor also. So around the straight conductor, the magnetic field lines are closed loops. So if the more magnetic field lines are there, if the field lines are more magnetic field will be there. Near the conductor, field will be more. Away from the conductor, field will be less. It depends on the distance from the conductor. So distance, according to the distance, the magnetic field changes. So that is about straight conductor. If the current direction changes, magnetic field direction also changes. And one more thing, Hans Christian Oersted observation they will ask for 2 marks. Hans Christian observation. So a compass is placed near a current carrying conductor, so got deflected. So suddenly it gets deflected. So he observed that one. So suddenly the compass is placed near a current carrying conductor, suddenly it's got deflected. So by that he conclude that the conclusion is there is a relation between magnetism and electricity. So there is a relation between electricity and magnetism given the relation. Okay, so that is the observation they will ask for 2 marks. And what is the SI unit of magnetic field, and like that, this type of questions they will ask. And coming to the next one, we'll go for magnetic field of bar magnet and magnetic for solenoid. Solenoid is nothing but if you are taking the straight wire bent in the form of cylindrical shape, taking the straight wire bent in the form of cylindrical shapes, taking the straight wire bent in the form of cylindrical shape that is connected to the battery. So it acts as a magnet. So bar magnetic field will be same as a solenoid magnetic field. So here similarities are there. Magnetic field will be there. Here also magnetic field will be there. So there magnetic field lines are there. Here also magnetic field lines. And here we can see, if you suspend the solid, always it shows north and south direction as bar magnet shows. Okay, bar magnet shows. And one more thing, so differences are very important. In bar magnet, magnetic field cannot be magnetic field cannot be changed. It is fixed one, bar magnet. Whereas solenoid magnetic field can be changed. So field poles also can be interchanged. In bar magnet, poles cannot be interchanged. And magnetic field can be changed in solenoid. In bar magnet, we can't change. In solenoid, how can by passing the more current, and if you increase the number of loops and air gap and gap between the rings, if you increases also, magnetic field will be increased. So that is about bar magnet and magnetic field of solenoid. And coming to the current carrying conductor placed in the magnetic field. Current carrying conductor placed in the magnetic field experience the force by using Fleming left hand rule. So Fleming left hand rule is very, very important. Stretch the left hand of thumb finger, index finger, middle finger. Index finger shows magnetic field. Middle finger shows the current direction. Thumb finger shows the force acting on the conductor. Force acting on the conductor. Only thumb. So for how can we identify the force acting on the conductor? By using Fleming left hand rule. If you stretch the fingers, so it's very easy. Along the magnetic field direction, index finger will be there. Along the current direction, so middle finger will be there. Along the direction of force, so thumb finger will be there. So like that we can identify. And one more point is, so you can go with we can go for that's enough. Short circuit is nothing but direct contact of live wire and neutral wire. Heavy amount of current will be drawn from the mains. And coming to the next one, overloading. If you on a high voltage appliances at a time, so like AC, geyser, fridge, water heater, so geyser only at water heater, like that. This type of high voltage appliances on at a time, then what happens? Heavy amount of current will be drawn from the mains. It leads to the short circuit, and then fire occurs. So live wire potential is 220, neutral wire is potentially 0, earth wire potentially 0. The difference between live wire and neutral wire, the potential difference between live wire and neutral wire is 220. The potential difference between live wire and earth wire is 220. The potential difference between neutral wire and earth wire is 0. So this is about potential difference. And coming to the potential difference in India is 220, and you can see frequency in India is 50 hertz. Okay, so number of oscillations by time taken, that is about frequency is equal to number of oscillations by time taken. So this is about the topic. So that is a complete topic we discussed till now, like from starting to ending. If you have any doubts, if you want any topic to be explained, let me know. So comment in the comment section. So if you have any doubts also from this chapter, you can ask me, I'll clarify. So like okay, so like the question format. If you have any doubts like magnetic field, properties of magnetic field lines, right hand thumb rule, left hand rule, so Hans Christian Ørsted observation, everything. So like that, if you have any doubts, you can comment. And if you want notes also, you can contact to this number if you want notes. So notes I have written. So these are notes like activity based. Actually, this complete chapter related to activity based. So all important points are arranged in that manner. So you can see this is my notes. So magnetic effects of electric current. So magnetic effects of electric current notes I have written. So you can see. So complete notes you'll get it. So like this. Okay. So here all the points I did, and all the points like activity. So you can observe. And a diagram related to diagrams also I did. So these are the diagrams. And here, so each and every point I formulated. So like that you can see. So I hope it is clear to you. If you want notes, you can let me know. Like this. So diagrams, all diagrams, and straight conductor. This question they given for 3 marks. So this is a here diagram also given. This is a right hand thumb rule, including hand diagrams. You can see the hand diagram. You can see the hand diagram, and here you can see all the points I did. So this is a solenoid diagram. Solenoid diagram. This is solenoid, and here, so this also current carrying solenoid is used to magnetize steel rod inside of it. If you place the steel rod inside of it, so it also gets magnetized. And here is see the diagram. So very important diagram. I only did with my hand. So like this you can see. Over short circuit, overloading, and earthing. Actually earthing is there, fuse and earthing also there. So those points. So that's enough for magnetic effects of electric current. Magnetic effects of electric current. If you like this video, please do like, share and subscribe to Student Day Brand. If you want the course, hi Shivani. Hi Shivani. So what happened? Now only you joined. Hi. So actually I completed the complete chapter. Just now only I completed. I'm showing the notes. Okay, done fine. So let me know which topic next I am going to plan. Light chapter. CBSE grade 10 physics. CBSE grade 10 physics course. Physics course only Rs 500 rupees. 500 rupees. Those who want this course, you can contact to this number 98498 9849812804. So you can contact to this number, phone number. Okay, so you'll get no sir, there was some glitch. My messages were not able to reach in chat now. I think they can. Okay. So you are there in class from starting onwards. I can see your messages now only. Maybe it is not reaching. So Tanishka joined. Few members are joined. Yes, sir. Okay. So you are there. Then why don't you ask questions? Did you message in the previous, no, in the class? Okay. Now only it is coming. Okay, that is a problem. Now I can see just now, end of the class, the messages were came. Only one message. Yes, sir, but I don't reach. Okay. Okay, anyway, you heard the chapter. Do you understand the chapter? Do you have any doubts? If you have any doubt, let me ask. You can ask now. If you have any doubts, you can ask. I'll clarify. So, like any doubt related to magnetic field and any topic, any concept, the explanation is required. Let me know. No, sir, I'm very clear. Very good. So I hope it is completed. So magnetic effects of electric chapter completed. Next, I will go to the light chapter. Light chapter tomorrow I will explain. So tomorrow 6 o'clock I am planning because it's Sunday. And Sunday 9 o'clock also. 9 o'clock class it will be fixed. Okay. Tanishka, still you are there. I thought you went. Okay, very nice. Okay, so tomorrow 6 o'clock, okay? Shall I take 6 o'clock? You can join at 6 o'clock also. And in 9 o'clock class also I am taking. 9 o'clock, see, 9 o'clock's different. 9 o'clock is fixed. Fine. Okay, Tanishka. See, I will take 9 o'clock class fixed. Whatever the reason it is, whatever the things are going on, definitely I'll start 9 o'clock and it will continue. So 9 o'clock is class will continue until 10. So I'll take. So actually it is completed. I'm concluding. No, that's the reason. So it's taking time. So by 10 o'clock I'll complete. So 1 hour class, 9 to 10. That is fixed. Remaining time I will let you know. 6 o'clock time I'm planning to take a light reflection and refraction chapter. So those who are interested, you can join to the class or you can join at 9 o'clock. 9 o'clock I'm planning to do same chapter, light chapter only. Same chapter, light chapter only. I'll explain. So those who can join at 6 o'clock can join. Those who want to join at 9 o'clock, so you can join. That is your wish. Choice is yours. Okay then. So nice to talk to you. Sorry for that. Actually, I want to tell one thing. So Tanishka and Shivani, yesterday I couldn't able to see the message because some technical issues. So while I'm taking the class, I'm continuously. That is the reason I thought. So people are like, joining and going, but no messages are not reaching to me. So I couldn't able to read. I couldn't able to get the messages. Okay, so that's the reason I couldn't able to respond to your messages. Sorry for that. So I'll so next class from next onwards, so I'll make it more clear so I can respond to your messages. So I'll respond to your messages. Definitely I'll answer to your messages. Okay. So that is for today class. So join. So I'm as I said, I will work on my efforts. Surely I will do my efforts to give the best. Okay. So related to CBSE grade 10 physics until the end. See, I'm planning to do the questions. So okay, question series. So daily few questions I'll take and I will work out. So practice session also I'm going to that and diagrams practice also like that. Okay, I planned everyday class related to grade 10 CBSE. It goes on continuously. So join. So don't miss the classes. Don't miss the classes. At least if that day is not possible at the end or starting, say at least hi to me. Okay, just respond to my class, and you can, if you have any work, you can do your work. Just come and join to the class and respond if you have any doubts. If not, so no problem. At least for saying hi, you can join and say hi, and you can leave the class. If it is any like emergency cases where we can't able to avoid those conditions. Hi Ria, how are you? So just now you joined. Very good. So you have to learn. So I'm taking 9 o'clock class every day. So better you can, if you join at 9 o'clock, it is good because I'm teaching extra. So I don't want to say those words because generally I used to say like that. So extraordinary, excellent, marvelous, mind blowing concept I'm teaching. So from 9 o'clock onwards, you can join at 9 o'clock. So I hope you are studying 10th class, is it? Okay, anyway, so it is too late. So we'll see in the tomorrow class. So 9 o'clock class. Yes, sir. Thank you so much. Nice to see you. Thank you. Bye. We'll see in the next class. Good night, all.